Hello everyone. So today we are solving another interesting problem number 438. Find all anagrams in a string, and I hope all of you are doing well. So it's been some time since I'm recording. So today we are going to solve this interesting problem. And without further ado, let's dive directly into the problem. And the problem says we have been given two strings S and P. Return an array of all the start indices of P anagram in S. You may return the answer in any order. So if the input is C, B, A, E, B, A, B, A, C, D, some string and another string P, and we have to tell that the what are the anagrams of P's in S and their start index. I hope you all remember the anagrams. So anagrams are nothing but strings whose characters are same. For example, if we have Eric, let's say is our string 1. uh, Let me write it this way. And if what actually I want to do is this. So this is the string 1, which is Eric, and string 2 is rice. Then S1 and S2 are anagram because they have the same characters E, R, I, and C. So that's why these are anagram. So, and in a problem we have this string C, B, A, E, B, A, B, A, C, D, and we have another string P, which is A, B, and C. So the thing that comes to me that how we can approach this problem. So what I can do is I want to create one hash map to see the count of characters in the in my p strings. So I will create one map of p which will give me the characters in p. So if I have a1, b1, and c1, so this is the frequency count of character in the string p. And similarly, what I will do is I will create the hash map for this string s, but here what I will do is I will keep one pointer r at the start of this string s, where at the length of string p, so that we only have to check for three characters in our window, such that we know, like currently in the hash map we have c one time, b one time, and a one time. And now what we'll do is we'll just keep moving our window. So we'll do is we'll keep our window moving along with our pointer. So that way what we'll do is we'll keep looking in this window. Now what we have BAE. So for to do that in the hash map, what we'll do is we'll delete this character and increase the character count of B in the S hash map and see if these two hash maps are equal or not. If they are, we'll hold that character value index in our answer string, in our answer array, add to add index to answer. Otherwise, just keep moving the window. So I hope you have understood my idea. So let me do it one more time, what I'm trying to tell. So now we are here. So let's move our character window. So currently we are here on this, and we are with the character R. We are gonna move again this window to here. So let me make a good window that we are gonna hold. So this, now we'll keep moving this window from left to right, and the character. So now here we have one E, and B is A time, and there is one E, and there is one B only, and we'll see that these two are true. If yes, then we'll add that character. If not, we'll remove that character. And one more thing that we will do is, uh, we'll just keep adding and removing the characters like we discussed. So without further any ado, let's dive into the coding part and see how we can model this algorithm visualization to code. So this would be the coding approach. So like we discussed, we'll keep one pointer R at the length, at the last of the length of the character P, and we'll need one hash map that has all the characters and their count, that we can do directly with the counter from the collections library in Python. And we'll have one hash map for the characters in S, and we want this until the first L characters, till the L characters of length P. So where our P ended, we want that window of constant size. And now what we'll do is, we'll check that if our two hash maps are equal, which is true in the first case, then we want to capture that character index value. So this was over here. So this is what we are observing initially over here. So that is that. So let me do one thing. Let me remove this. These are dividing us from our, and we'll make one separate window. We'll make a separate window that will move. So I hope that will help to visualize this problem more. And let's log all these together. So this is one part, and we want to move all these together as we are moving in the window, and we'll keep checking the count of the characters in this window. So this is the approach, and we want the where our character first appeared. So that would be at r minus l distance. And now we'll start looking for every character until we have exhausted the total length in the character s. So for that we need one variable that holds the count of character s, that hold the length of character s, and until the right pointer is below the total characters length in s, we're going to do the loop. And for the first time when we enter the loop, we see that character where our pointer is located. We are gonna add that character from right into our hash map, and from left we want to delete the character. So that would be the character that is outgoing is coming from r minus l. So this is the outgoing character into our hash map, and as soon as that character found in the hash map becomes 0, so that is s of r. If this becomes 0, then what I want to do is I want to remove that character permanently from the hash map that we have constructed. So that is delete s of r minus l. So this is the outgoing character, and if its character count becomes 0, then we want to delete that character. And as we are checking for that particular window length in the both the hash maps of s string and p string hash map, and if they are equal, then we want to grab the index at r minus l plus 1, because we are accepting one character from the right. That's why this plus 1 is there. So, and in the end we want to return our answer. So that is the solution. Let's run our code and see how it performs. So it is saying that answer is not defined. Yes, we have not defined any answer list to hold that. Now let's run our solution. Okay, so it has been accepted, and let's submit it for all the test cases and see how it performs. So it has been accepted and it's running pretty fast and it's good. So yeah, that's how you solve this problem. I hope you learned something new today with me, and let me know if you have any particular problem for me to solve, and I will see you tomorrow with some new algorithmic problems. Till then, be safe and have a nice day.